Okay, very good afternoon, grade 7. Today, as I told you last week, that today, tomorrow, and maybe another day, I would be solving the questions with you, the previous worksheets that we've done. We start off with Unit 7, end of unit questions. The first question there, 7.1 is, litmus is a dye made from living organism. It is red in acid, it is blue in alkali, and it is purple in a neutral solution. We've already studied on the pH scale. Acid is 0 to 7. Alkali is 7 on the other sides. It's actually, yes, 7.1 onwards until 14. And the neutral pH is 7. Okay. Now, let's begin answering. A is, what is the correct scientific term for a substance that changes color in this way? Now, it is indicator. So, what are they talking about? They are talking about the substance. Now, which is the substance? That is what is written in the first sentence. That is, litmus is a dye that is made from a living organism. Okay? Now, so B says, what color is litmus in a solution of pH 4? Now, you can see the second statement written there. It is red in an acid. What is an acid? The pH of acid is less than 7. So, pH 4 is an acidic pH. So, what would be the color? It would be red. Now, C is, what color is litmus in pure water? Pure water is neutral. So, what would be the color? It would be purple. Is that clear? Next, 7.2. Now, there are some words or phrases that are written here and they are associated with acids or with alkalis. So, words associated with acids, if you look at the pH scale, again the use of universal indicator. So, an acid's universal indicator, which is also written as capital U and a capital I, it turns red. Okay. And which is the other word? It would be pH 2 because 2 is lesser than 7. Sour. All acids are sour in taste. We studied before. And lemon juice. That is, all citrus fruits we know are acidic. So, this is acidic. Now, obviously, the other words associated with alkalis is that makes UI or universal indicator turn blue. It has a pH of 9 and with toothpaste, and the next word is soapy. I hope it's clear. Now 7.3. This truck is unloading acid at a factory. Okay, and you can see that there is a hazard warning. So the question reads, the driver has placed a warning notice nearby. Explain why this is important. Why is it important? If he doesn't put a notice like that, it could lead to an accident. B is, suggest what could be done if there is an accident and some acid is spilt onto the ground. Now, in case by chance there is an acid that is spilt on the ground, so explain your answer. What would we do? Immediately, anytime, remember, whenever there is an acid that has fallen, you could either use an alkali to neutralize the acid, or you could immediately put some water to dilute it. In this case, the water adding would be a little difficult. So, immediately the alkali is added to neutralize the acid. The next page, the last question that is there, that is to plot a graph. Okay, this plotting of the graph, I wish all of you do it. But question number A in 7.4, you can see this is the diagram and it says Aaron and Ben put 50 cubic centimeter of alkali into a conical flask. They added universal indicator to the alkali. So there are two students, Aaron and Ben, What have they done? They have just added 50 cubic centimeter of alkali into a conical flask. And to that they have also added alkali. Sorry, they have added the universal indicator. Now, they've used a burette to add acid to the alkali. Okay, so always burette is opened drop by drop and the acid is added to the alkali. The acid was added 10 cubic centimeter at a time. Okay, the student stirred the contents of the conical flask. It's very important, stirring. Stirring is mixing, so you can use a glass rod or you can just lift up the conical flask and swirl it. Okay, make it go round and round. And each time they added some acid. Aaron and Ben, what did they do? They also recorded the pH after each addition of acid. So how does it go? The volume of the acid added is the first column. That says 0, 10, 20, because here it's already written that the acid was added 10 cubic centimeter at a time. 20, 30, 40 and 50. And what about the pH? You see the pH is reducing. Why is the pH reducing from 12? So initially the alkali is not 14. Okay, it is 12. So from 12, once a little bit of acid or 10 cubic centimeter of acid is added, how much does it become? pH becomes 11. Then when you add 20, it becomes 10. Then 30, it becomes 9. 40, it becomes 8. And 50, it becomes 7. So you can see there is a gradual change of 1 pH value for every 10 cubic centimeter. Is that clear? This table, that is what it says. Now, so the first question A, what color was the solution at the start? You can see the start, it was purple. Okay. What was the color of the solution at the end? At the end, when it is, they have added 50 cubic centimeter. What would be the color? It would be green. Now, which one of these statements is correct? Does it the acid was stronger than the alkali? The alkali was stronger than the acid, or the acid and alkali were equal in strength? Now, why have I ticked that? Look there. How much did you add before in the conical flask? 50 centimeter of alkali. How much of acid was needed to neutralize it? 50 cubic centimeters. So, the acid and alkali were equal in strength. Okay. So, explain your answer. That's what exactly I've written, as the volume of each acid added was also 50 cubic centimeter. Is that clear? Now I want you to draw a line graph. Come on, this line graph all of you can do. On the x-axis, you put the volume of the acid that is added, and on the y-axis, put the pH. The same table which you have it here, you will put it in the graph. Take a graph sheet and put the volume in the x-axis and pH of the solution in the y-axis. Well, that's because they have put your pH here. What will happen? As the volume of the acid increases, you will see this will be a graph which will not go from bottom to top. It will come down from 12 to 7. So it will be a graph, a line graph that will be sloping down. The readings are from 12, 11, 10, 9, 8 and 7. Is that clear? Okay. Thank you. Please write down these answers in page number 102 and 103 and stick the graph also there. Okay. Thank you. Have a great day, and until tomorrow when I take up the other worksheets.